Intermolecular forces. What types of bonds exist between molecules? Objectives. Distinguish between intramolecular and intermolecular bonding. Describe dispersion forces. Explain how size and shape of a molecule affect dispersion forces of attraction. Describe dipole-dipole interactions. Describe hydrogen bonding. Intermolecular forces. Intramolecular forces occur inside molecules. Example, the covalent bond within an HCl molecule. Intermolecular forces, on the other hand, occur between two molecules in the solid and liquid states. Example, between two HCl molecules. Intermolecular forces. There are three major types of intermolecular force. They are dispersion forces, dipole-dipole attraction, and a special case of dipole-dipole attraction called hydrogen bonding. Dispersion forces occurs between nonpolar and polar atoms and molecules, while dipole-dipole attraction occurs in polar molecules, and hydrogen bonding occurs between molecules containing fluorine, oxygen, and nitrogen. Intermolecular forces affects the boiling point, melting point, and vapor pressure of a substance. Dispersion forces, also known as van der Waals forces. Dispersion force is a temporary force that forms when the electrons of two adjacent atoms occupy positions that make the atoms form temporary dipoles. These temporary dipoles leads to a partial positive and a partial negative charge, and the result is an attraction between them. This is known as a dispersion force. We also can have an atom, for example, neon. Two neon atoms next to each other can also have a dipole within the atom where the electrons are more towards one side, resulting in a positive and a negative charge, a partial positive and negative charge, producing a dispersion force, an attraction between the two atoms. Dispersion forces are present between all polar and nonpolar substances. Dispersion forces. Molecular size and its impact on dispersion forces. The larger the size of a nonpolar atom or molecule, the greater the attractive force. In larger atoms and molecules, the valence electrons are further from the nucleus compared to smaller atoms, and the electrons are less tightly held and can more easily form temporary dipoles. For example, the halogens. The larger bromine atom has greater intermolecular force, dispersion force, than a smaller chlorine or fluorine atom. This results in bromine being a liquid at standard temperature and pressures compared to fluorine and chlorine, which are gases at standard temperature and pressure. The noble gases also express this, where the larger krypton molecule has a much higher intermolecular force compared to argon or neon, or even helium. Hydrocarbons also show the similar properties. The larger molecule butane has a much higher intermolecular force compared to propane, ethane, or methane. Molecular shape and its impact on dispersion forces. The more region of a molecule exposed, the greater the attractive force. Example, pentane, the straight chain structure, has greater attractive force than the branch chain structure. Practice question. At STP, fluorine is a gas and bromine is a liquid, because compared to fluorine, bromine has stronger intermolecular forces. Bromine is a larger molecule compared to fluorine. Therefore, it has more dispersion forces, and their intermolecular force is much stronger between molecules of bromine. Second practice question. Which characteristic of the compound C5H12 causes it to have a higher normal boiling point than C2H6? The force of attraction between the molecules of C5H12 is greater. C5H12 is a much larger molecule compared to C2H6. Therefore, it has a greater dispersion of the electrons in the molecule, so there will be greater dispersion forces between them. Dipole-dipole interactions. Dipole-dipole interactions occurs between polar molecules. That forms between the positive end of one polar molecule and the negative end of another polar molecule. Here we have HCl. One side is partially positive and the other is partially negative, and a dipole-dipole interaction occurs between them. Polar molecules have partial positive and negative ends. The partial positive end of a polar molecule is attracted to the partial negative end of another. In the HCl molecule above, the more electronegative chlorine atom has a partial negative charge, while the less electronegative hydrogen has the partial positive charge. The partial positive end of the one HCl molecule is attracted to the partial negative chlorine end of the other HCl molecule. Hydrogen bonding. Hydrogen bonding is a special type of dipole-dipole interaction. Hydrogen bonding occurs between hydrogen atoms and other highly electronegative atoms. These are fluorine, oxygen, and nitrogen. And a way to remember these would be the fun molecules, FON. Let's explore ammonia. We have NH3, two molecules, and between the hydrogen atom of one NH3 and the nitrogen atom of another NH3 exists hydrogen bonding. Another example would be water. Here we have two water molecules, and between the hydrogen of one water molecule and the oxygen of another water molecule, hydrogen bonding occurs. Hydrogen bonding also can occur between other types of molecules, for example, between NH3 and H2O. It is not, however, between two hydrogen atoms. Hydrogen bonding does not occur between two hydrogen atoms. It is between hydrogen and another highly electronegative atom, and these are fluorine, oxygen, and nitrogen. These three only. Hydrogen bonding. Hydrogen bonding is responsible for the high boiling point of water compared to other molecules of similar size. Here we have hydrogen bonding occurring between the oxygen and the hydrogen of the various water molecules. Concept check question 1. Molecules in a sample of NH3 liquid are held closely together by intermolecular forces. Caused by unequal charge distribution. Concept check question 2. Based on intermolecular forces, which of these substances would have the highest boiling point? NH3. All the other substances are non-polar, while NH3 is a polar substance and would have hydrogen bonding between its molecules. Concept check question 3. At STP, fluorine is a gas and iodine is a solid. This observation can be explained by the fact that fluorine has stronger intermolecular forces of attraction than iodine. Question 4. Which compound has molecules that form the strongest hydrogen bonds? HF. Fluorine is the most electronegative element, therefore it will have the greatest attraction for the electrons shared between H and F, making it very polar, and it would engage in hydrogen bonding. Question 5. Which statement explains why Br2 is a liquid at STP and I2 is a solid at STP? Molecules of iodine, I2, have stronger intermolecular forces than molecules of Br2. Since iodine are larger, they would have greater dispersion forces between atoms of iodine compared to atoms of bromine or molecules of bromine. Question 6. Which compound has hydrogen bonding between its molecules? Hydrogen bonding occurs between fun molecules, fluorine, oxygen, and nitrogen. NH3 is one of the atoms in the fun molecules, nitrogen, therefore NH3 will have hydrogen bonding between its atoms. Question 7. The relatively high boiling point of water is due to water having hydrogen bonding. Question 8. Hydrogen bonding is a type of strong intermolecular force. Question 9. Which group 16 element combines with hydrogen to form a compound that has the strongest hydrogen bond between its molecules? Oxygen. Oxygen is one of the fun molecules, FON, fluorine, oxygen, and nitrogen, and it engages in hydrogen bonding. Question 10. Which compound has the strongest hydrogen bonding between its molecules? HF. F is the most electronegative element of the answer choices, therefore it will have the strongest attraction for the electrons and therefore have strong hydrogen bonding.